quadratic equation formula and how it was derived. We will provide a proof that will be done algebraically. We will begin with the quadratic equation itself and set it equal to 0. The quadratic equation is of the form ax squared plus bx plus c. We will set that equal to 0. And step 1 will be to divide by the leading coefficient. Now what the leading coefficient means is the numerical value that goes before the variable with the highest exponent. So the variable with the highest exponent is x squared, and the coefficient, the number that is associated with that variable, the number that's in front of it, is the a variable, the a letter. So what we will do is we'll divide both sides by the value of a. Now a is an arbitrary number, so we'll divide it by a on all sides. That means this implies that it can be any number, as long as a is not equal to 0. As long as a does not equal 0, because we are not able to divide by 0. Once we will divide all the terms of this quadratic equation by 0, the following will result. We will have now x squared plus b over a x plus c over a equals 0. The right-hand side is always going to equal 0 because 0 divided by anything except for 0 is going to just be 0. The next step will be the following. It will be to utilize the idea of getting rid of the constant. Now, the constant in the quadratic equation formula is the c over a term. We will eliminate this by using an inverse operation. This implies that we will be subtracting c over a on both sides of the equation, from the left-hand side and from the right-hand side of the equation. Now, as soon as we perform the subtraction on both sides of the equation, a resulting equation will be formed of the form x squared plus b over a x equating to negative c over a. Now, you may ponder, why would I go ahead and subtract c over a from both sides? What would that provide for me? Well, it will provide the following, if, of course, you can recall and utilize this trick. The trick I'm about to show you is known as the completing square method. So the completing of the square method states the following. If you take the second term that's on the left-hand side, we'll write that on the left-hand side here, and you divide that term by a factor of 2, and then square it, you will then be able to add that term to both sides and simplify the expression, the equation. So let's look at what we have. B over a over 2 is equivalent to saying b over 2a. Now don't forget, we still have to square this term. And b over 2a squared is equivalent to stating b squared over 2a to the squared, where 2a is within the scope of your parentheses. And we can proceed further by writing it as in the following manner. B squared over 4a squared. Now this term here that's on the left-hand side, we will now apply to the equation that's on the right-hand side. So we will be adding b squared over 4a squared to both sides of the equation. So we will have the following. We will have x squared plus b over ax plus b squared over 4a squared equaling b squared over 4a squared minus c over a. Now to simplify matters, we're going to move to the right-hand side for a moment, and we'll try to combine those two fractions. Recall, in order to combine two fractions, you need to have the same common denominator. Now, one way you can get those two denominators to be the same is if you multiply one of the fractions by a factor, such that when you get the product, it will result in the same value for both denominators. So look at the left-hand denominator, that's 4a squared. On the right-hand side, you have a. So your objective will be to convert the a into a 4a squared by some product. And this can be done easily by multiplying the top term and bottom term by a factor of 4a. Now, what this will provide for us is the following equation. We will get x squared plus b over ax plus b squared over 4a squared, equating to the difference of b squared minus 4ac over 4a squared. Now notice in the numerator you can see what we call a discriminant. We'll talk about that hopefully soon. Now that we're on the left-hand side, it's important to note that the expression that we have on the left-hand side can be condensed. Now recall, completing the square method allows you to write an expression in a more condensed form. So we will write it in the following fashion. We will have it as x plus b over 2a. Now, how did I know it was going to be over 2a? Well, the term that's going to be inside the parentheses that you're going to add to the variable x is always going to be the second term divided by 2. Remember, in the original expression, we had x squared plus b over a x equals negative c over a. Well, that second term divided by 2 will be the term that you will write in the condensed form. And of course, this whole thing will be raised to the power of 2. We will now set this equal to b squared minus 4ac over 4a squared. Now, the objective is to solve for x. So what we will do is we will take the square root on both sides. When you take the square root on both sides, the square from the left-hand side vanishes. It gets eliminated. So you are left with x plus b over 2a. On the right-hand side, since you're taking the square root of a number, you have two possibilities. You have a positive as well as a negative possibility. And this is because, for example, if you take the number 4 and multiply it to itself, you'll get 16. But you can do so also with negative 4, such that if you multiply negative 4 to itself, you'll also get 16. So the square root of any positive number can be found as a positive or a negative value. So therefore, we have the following. The square root of b squared minus 4ac. And of course, on the bottom, we will also have to take the square root of that. And I'm just going to simply write it as the square root of 4a squared for the time being. Now to simplify the right-hand side, you will have the following. X plus b over 2a equals plus minus the square root of your discriminant, b squared minus 4ac, over 2a. Now your discriminant will tell you a lot about your roots, how many roots you have in the equation, whether they're real, they're imaginary, and so on and so forth. But that will be probably for another video. Now the last thing to do to solve for x is to subtract the factor that's on the left-hand side, the term that's on the left-hand side. And that term is negative b over 2a. If I proceed by subtracting negative b over 2a from both hand sides, the following equation will result, and I will have it of the form that I desire. I will have it as x equals negative b over 2a plus minus the square root of b squared minus 4ac all over 2a. Now notice those two denominators are indeed the same. So therefore, we can go ahead and just write them as one denominator. So negative b plus minus the square root of b squared minus 4ac over 2a. And there you go. There you have it. You have the equation, the quadratic formula equation that we need. And that's it.